Hi, we're the ball launching robot. I'm Andrew Nguyen.
I'm Chris Bennett.
I'm Sepanta Shekarchi.
And we're going to first start with the goal and motivations.
Our main goal is that we want to make a robot that allows a dog to play fetch with itself. Our motivations for this project include aiding owners who can't play fetch with their dog anymore, and to learn more about the engineering behind a pitching machine.
There are two prevailing designs for ball launching: a pneumatic cannon-style launcher, which uses pressurized air to launch a ball through a barrel, and a mechanical launcher that uses roller wheels to accelerate a ball forward. While the pneumatic air cannon would be a more simple and tried-and-true method, it is potentially less consistent and complex for the scope of this class. With the roller design, we could apply what we have learned in this class to a better degree. For example, motor characteristics, power consumptions, and other methods we've learned. Here we've done some preliminary testing on our ESCs and our motors. We just checked to verify that the motors are working and the ESCs are working as functioned. We used the code from RZtronics to send PWM signals to the ESCs that will power the motors. Here's a quick video showing that.
As for the coding, I developed a pseudocode to understand the logic of our device and determine the appropriate electrical components and mechanical design of the device. Running through this basic pseudocode, we use a sensor to notify the system that the ball is in place and use state variables to activate and deactivate our actuators. A timer is established as a logic check for the states. We also establish 3 switches for different user preferences depending on whether they are indoors or outdoors. Lastly, after a certain amount of time, the state returns to 0 and the actuators reset, waiting for another ball to drop.
This is a preliminary circuit design in schematic form. The circuit was designed with easy EDA, and the main features of the electrical mechanical design are 2 DC brushless motors for the flywheels and their respective electric speed controllers, the servo motor used as a loading mechanism for the launch chamber, and an IR brake beam sensor that detects when the ball enters the chamber. If time permits, we'll use a piezo speaker to alert the user for different stages of launch, and push buttons that will switch between user-designated modes.
Our CAD design was done on SolidWorks. The design is a tennis ball pitching machine. The intended materials for this project include 3D printing for the pitching machine mechanism, scrap wood for the funnel, and rubber wheels for the motors. The design idea is to have a ball be dropped by a dog onto the funnel and let gravity bring the ball to a catch. Our catch is custom made to stop the tennis ball in between 2 ramps. There are 2 slots for IR brake beam sensors with the necessary holes underneath of them for wiring. Also, the bottom of the catch has an attachment point for the servo. After the catch, the servo loads the tennis ball into a pitching chamber slowly, thus launching the tennis ball away. The chamber is designed to funnel the ball even more so it doesn't collide with the sides. It also has 2 slots on either side for the wheels and is cut at an angle to not trap the ball before the wheels. Lastly, the chamber has a cutout on the bottom to have guide rails for the motors. The guide rails will allow us to launch the tennis ball optimally from whatever place we want them.
Our flywheel energy estimates predict that we will have a 45.5 meters per second launch velocity using 800 kV motors at 11.1 volts. We also used the peak output current at 55 amps with the 25C battery and ESCs. We also predict that our max RPM is going to be 8,800 RPM.
Bill of materials. All items we buy or repurpose from other projects are on the list, excluding any nuts or bolts. Our estimated cost right now is about $75.
Next is our member roles.
Hi, I'm Chris. I'm responsible for any designing and mechanical work.
Hi, I'm Andrew. I'm in charge of electrical design and wiring of the components.
Hi, I'm Sepanta, and my role is writing the Arduino code and the logic of our device.
Thank you so much for your time and attention. We hope you enjoyed our presentation.
We hope to have our robot fully functional by week 10.
If you have any comments or suggestions, please let us know. Thanks for watching our video.